Hello students, welcome to our new lecture. Let's first of all discuss that what we had done in our previous lectures. So in previous lectures we have started our normal forms in which we have picked that what is Chomsky normal form, which says that in Chomsky normal form any grammar will be in two types, that is A produces X, Y, or A produces beta. Here X and Y are two terminals, which means any production will be either in two variable format, exactly two variables, or single terminal format. So if any particular production rule is in either in these one, and if all the rules are in these forms, then the grammar is known as Chomsky normal formalized grammar. Now the next grammar is GNF, Greibach normal form. Now before I'll discuss about Greibach normal form, let's first of all discuss one very interesting topic, that is left recursion. Now, the thing is that what is actually left recursion? I hope that you know what is recursion. Recursion is function calling to itself. Now, in grammar also we have recursion, but there is one specific kind of recursion. For example, suppose you are having A produces A alpha slash beta. Now what will happen here? Here A is calling to itself. So once I'll try to derive any particular string, what it will do, it will start with A produces A alpha, then again A produces A alpha. In such a way I can move A up to infinity. So when I need to put this beta, so that is known as left recursion, that there is a possibility that A will move into infinite loop. So if any grammar is having left recursion, how to remove it? So for removal of left recursion, there is one formula. So let's pick that formula. Formula says that if grammar is having left recursion, for example, let's take the same one, A produces A alpha slash beta. Formula says that A produces beta, assume one variable, suppose A dash slash beta, and A dash produces alpha A dash slash alpha. Now this is same like this particular thing, that is A produces A alpha slash beta. If I want to remove left recursion, this will be by using this formula, which says A produces beta A dash slash beta, and A dash produces alpha A dash slash alpha. Now the thing is that why we are having certain formula for it. If it is, suppose for example, if it is A dot alpha, means A multiplied by alpha, and if I'll write A produces alpha A, then again I'll get the same thing, because multiplication have no issue. But the problem is that in grammar it is not true. If you want to remove left recursion by simply swapping it, what it will give you? This will give you things alpha, beta. But if you are having A produces A alpha slash beta, you will get beta alpha. So you have done alpha A, but what you want result is this one, which is not possible by this alpha A dash. Hence, you cannot straight away swap to remove the left recursion. So the thing is, how I got this particular answer, why I am having this thing. So if you want to check, although it's not really necessary to know about this thing, but still let's try to pick that A, what I am actually using A, that A is to repeat and get alpha multiple times. So what I am going to do, I am going to utilize the same concept that I want alpha multiple times, that is A dash. Hence A dash, from A dash what I can get? Multiple times. And at the end, to repeat it and complete it, I require again alpha. But if you will see this thing, A is producing beta, and we had checked that which kind of string I'll get, beta, alpha, 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 and so on. Is it right? So what I'll get here, it's starting with beta, so I'll say A produces, it can have either beta or beta A dash. So from A dash, if I'll put up this value, I'll get beta alpha. So that is the actual thing as a formula. This is actually known as Ender-Backus-Naur form, through which this formula gets generated. So finally we got one formula for removal of left recursion. Now once again let's repeat that what we have done so far. We have picked that there can be possibly you are having in your grammar left recursion. Now what is disadvantage of left recursion? Disadvantage of left recursion is that your grammar can move up into infinite loop. This is simply like for example, you have in C, you have one function and function calling to itself, and after that you are having x produces a, y is equal to b, something like this. So what it will do, it will call, this is known as head recursion. So if you want to utilize these things, what you can do, you can add this head recursion to the tail recursion, so that you can get effective results. But just because you had put it this is in head recursion, it will move up to infinite without moving into these lines. Hence the same problem is here, and that is the main reason we want to remove the left recursion. So how to remove left recursion? We got one formula. Formula says that A produces whatever after this particular production, whatever values you are having, beta A dash and all those values. Similarly, A dash or new variable will be alpha A dash slash alpha. So this is a removal of left recursion. Now let's take one example and try to remove left recursion. Suppose I am having E produces E plus T slash T. Now I want to remove slash T slash, suppose slash A slash B. suppose this is what I am having. Now I want to remove this left recursion. So how to proceed for this thing? The formula says that A produces beta A dash slash beta. So I am going to utilize the same thing. Here if I check and map what I am having, here the E which I am having, that is in my previous example it was A, and beta is A and B both things. So if I want to generate, now what I am having, A produces beta A dash slash beta. So here I am going to use E produces beta A dash, which says A, suppose instead of A dash I am taking here E dash slash B E dash slash A slash B. So this becomes beta. Now E dash will be, now what I want alpha A dash slash alpha. Now what was alpha over there? Alpha was after A whatever you are having. So here after A what you are having, plus T. So this becomes plus T E dash slash plus T. So this is the particular grammar without left recursion. In this we are having left recursion. Here we have removed left recursion. So I hope you got that how to remove left recursion. This is very useful thing. Once you will move in compiler design, again you require this particular removal, and in next topic, that is our GNF, we are going to utilize the same concept. So be careful and carefully pick that how to remove left recursion.